Good morning, everyone. In last class, we were studying about compound stresses. In that compound stresses, you already know we used to consider the two-dimensional plane, two-dimensional point here. This is the one point you can call, or otherwise a plane. There, stresses will be acting in mutually perpendicular direction, only in x and y direction. That is sigma x and sigma y. This is sigma x, sigma y, and there will be some shear stresses acting. You already know the sign conventions of all these, and even we derived an equation. Say for example, if you have one plane like this, and if a general stress system is applied to that, general stress system means sigma x is also there, sigma y normal stress is also there, and along with that shear stresses is also there. Then this is called as a general stress system. Here, if I have an interested plane, this is an plane of interest. This is called as plane of interest. Plane of interest. This plane of interest is making an angle theta with respect to vertical. On this plane of interest, there will be two type of stresses. One is perpendicular to the plane, one is parallel to the plane. One is perpendicular to the plane and another one is parallel to the plane. Perpendicular to the plane, we will call it as a normal stress, that I will call sigma theta, and parallel to the plane we will call it as a shear stress, that is sigma theta and tau theta. Right? And in the last class we derived an expression for sigma theta, that is your sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta. Right? Then tau theta is equal to sigma x minus sigma y by 2. See, this I written here, and cos theta, instead of cos theta here it comes sin 2 theta, and instead of plus it will come minus, and tau xy as it is, and instead of sin 2 theta here cos 2 theta. Right? Okay. These two equations we derived. Okay. Then what these two equations indicates, you should be very clear about the meaning of these two parameters, sigma theta and tau theta. They are stresses on plane of interest. Once again, they are stresses on plane of interest. Once again, they are stresses on plane of interest. Okay. Means here the word interest is there, means whose interest it is. Whose interest? It's my interest. I am dealing with this body, therefore it's my interest. And if you are dealing with this body, then that is your interest. Like that, whoever is dealing with this one, that is their interest. Like that, in general, if I have one plane like this, then how many plane of interest I can have? How many plane of interest I can have? That I can have infinite plane of interest. Say I am interested here, someone interested here, someone interested here, someone interested here, someone here, someone here, someone here, someone here. Say how many plane of interest I can draw? I can draw infinite number of plane of interest here. Right? These all plane of interest, if I put in some standard way, then I will get this diagram. Say for example, I am interested in this plane, someone may be interested on this plane, someone may be interested in this plane, someone may be interested in this plane, someone may be interested here. See what I am doing here, I am just somewhat uniformly I am drawing. Means everyone will be having their own thetas. See, these thetas are different, these thetas are different. Means if you are interested on any particular plane, then how you represent? You have to represent it by theta. Now without drawing this one, I can say that, sir, I am interested in 1 degree theta, I am interested in 2 degree theta, I am interested in 3.5 degree theta, I am interested in theta 45 degree plane, I am interested in 60 degree plane, I am interested in 355 degree plane. See, how many interests can be generated? Many interests, from 1 degree to till 360 degree. Even if you can consider fractions also here, therefore there will be many plane of interest. This you understood? This did you understand? Then if you are okay with this, means every plane will have infinite number of, or otherwise somewhat very number of planes that can have. Now the question is, in this equation sigma theta equal to sigma x plus sigma y by 2 cos plus sigma x minus sigma y by 2 cos 2 theta plus 2 xy sin 2 theta. Then tau theta equal to sigma x plus sigma x minus sigma y by 2 sin 2 theta minus tau xy cos 2 theta. In these two equations, for a particular plane means, let us consider this plane has some sigma x and this plane has some sigma y and this has some tau xy, For this particular plane, how many planes I can have? I can have number of planes. By varying what? By varying theta. Then what I am keeping constant when I am varying theta? When I am varying theta, I am making sigma x and sigma y and tau as a constant. They are considered constant, and which is varying? Theta is varying. Understood? Means in this equation, as I go on putting this theta value, different theta values, then I will get different sigma theta and tau theta values. Will you agree with this one? If not, then go back, just rewind the timeline and go back and again understand. Okay, now if you are okay with this, okay with what? By varying thetas, I can have different values of sigma theta. I will have a different values of tau theta. Agreed now? Then if I draw one Excel, there if I draw this as a theta values which is varying continuously from 1 degree to 360 degree, it may vary. Then corresponding thetas, the corresponding 1 degree corresponding, I can calculate sigma theta. For this corresponding 1 degree, I can calculate tau theta. Like that, I can have one more column here. Okay, now this I can have only by varying this theta value. Okay, agreed? Now the common sense if you use, then in this list of sigma theta from this point to the end point, there are many values are there here. Many values are there. Out of all of them, you may get one value as a leader. Leader means what? Maximum. Out of these all values, one value you may get maximum, and one value somewhere you may get minimum. You will get minimum. Then this value we will call it as a sigma 1, and this value we will call it as sigma 2. Sigma 1, what it represents? Sigma 1 is a maximum normal stress. Where? On a particular plane. Then what is sigma 2? Sigma 2 is a minimum normal stress. Where? On a particular plane. The interestingly, on this plane, sigma is normal stress. Normal stress is maximum. What about shear stress? On this plane, that is very interesting, that becomes 0. The same thing, sigma, this theta means sigma 2. Sigma 2 is a minimum value. Where it is minimum? On this plane. On this plane, what is shear stress? Again 0. Very interesting, no? This I will get it. This I have to get it. Mathematically I can prove it, that wherever sigma 1 is there, their shear stress is 0. Wherever sigma 2 occurs, their shear stress is 0. This I can prove you. Therefore, these planes, this plane and this plane, are called as principal planes. But two principal planes are there, no? One here and one here. Therefore, we will name the first one is major principal plane. And the second one is what? The second one is minor principal plane. Minor principal plane. You distinguish between the two principal planes. Then can you define what is principal plane? Principal planes are the planes on which normal stresses are maximum or minimum but shear stresses are zero. They are called as principal planes. Very easy. You can pass it down and note down the definition. Principal planes are the planes on which normal stresses are maximum or minimum and shear stresses are zero. Then why we are called major principal plane and minor principal plane? Because major principal plane name is given where normal stress is maximum, minor principal plane name is given when the normal stress is minimum. And then these two normal stresses are called as principal stresses. Principal stresses. Then again principal stresses are two types. One is a major principal stress, and the second one is minor principal stress. Then what is the difference between major principal stress and minor principal stress? Which is maximum normal stress, that is major principal stress, which is minimum normal stress, that is minor principal stress. Very simple. Then define principal stresses. Principal stresses are maximum or minimum normal stresses on principal planes. Okay, this is a theory about the principal planes. Then I need to derive an expression saying that on a particular plane where normal stress is maximum, shear stress is zero. This I have to prove to you. Understood? This is very important. And the second very important thing here and very interesting thing is here, whatever the theta value you are observing here and this theta value whatever observing here, if you compare these two, you are getting difference as 90 degree. The difference between these two angles, that is mathematical difference between these two angles is what 90 degree means. I can say that major principal plane, minor principal planes are perpendicular to each other. See how interesting, no? Perpendicular to each other. Okay, no? This I got. Now, what I did, you just see here. I considered this table. On that I got one maximum normal stress and one minimum normal stress. The same way, if I concentrate on this side, here also in this table, in this column, I can get somewhere tau is maximum and somewhere I can get tau is minimum. You know, this I will call tau 1, this I will call it as a tau 2. This I will get a tau 2. The very interestingly, where I got this tau max? Tau max I got on particular shear plane. This is called a shear plane. A particular shear plane I got tau as a maximum. Then on the shear plane, what is normal stress? It is not zero. It is the average of sigma 1 and sigma 2. Then wherever the plane is there, on that plane where tau is minimum, on that plane the normal stress is sigma 1 plus sigma 2 by 2, average of principal stresses. Understood? This is very important. This I will call it as a theta S2. Then again the very interesting thing I can observe, theta S1 and theta S2 are perpendicular to each other. Right? Principal planes are perpendicular to each other, shear planes are also perpendicular to each other. Then what is the comparison between principal planes and shear planes? They are 90 degree, no, 45 degree to each other. See, principal plane, shear plane. See, shear plane 90 degree, principal plane 90 degree. But shear plane, principal plane 45 degree. Right? This is how they will be arranged in a particular element. If this is a principal plane, this is a minor principal plane, this is a shear plane, this is a minimum shear plane. Like that we will get 4 planes on the particular body. Now in this class, this is enough. just you understood that what all are there in the element, what all we can study in the element. In the next class what we do, we whatever I told till now, these all interesting points whatever I told till now, that I have to prove it mathematically. Therefore next class I am going to derive an expression for principal stresses and their orientation, and shear stresses, maximum and minimum shear stresses and their orientation. Right? Thank you.